Okay, so guys, we are working in 12.2 and in 12.3. When we do this, we're going to be working at two different types of sequences. Sequence is just a set of numbers, and the set of numbers might have a pattern. And if it has a pattern, we're going to classify it into one of two types of patterns. Either arithmetic, which looks just like arithmetic, or geometric. Those will be our two different versions. 12.2 will deal with arithmetic, and 12.3 will deal with geometric. And so what we're going to do is we're actually just going to jump right in and start looking at a problem and try to identify that it is one type or another, and then what we can do with it. So the first thing we want to do is we're going to look at number 14 from 12.2. And number 14 gives me a sequence that has 8, 21, 34, 47, and 60. And then dot, dot, dot. So the sequence can go on forever, infinitely upward, as we see it climbing. We want to confirm that it is arithmetic. The way we do that is by checking that we're adding or subtracting something. If it's subtraction, that's fine, or if it's addition, that's fine, but it's got to be the same value each time. Well, 21 minus 8 is 13. 34 minus 21 is 13, and again, and again. This is going to work out really well for us because we've just shown that the difference is always 13. That makes this arithmetic sequence. Next, we need to try and write an equation or a formula for this sequence. Well, the expression that we have from class is an equals, and then it's a1 plus n minus 1 times d. Now, important things to note are that a1 is the first term, n is the number of terms I'm going through, so we're going to leave that as a variable for now, and then d is the difference between each term. And so what I'm going to have is an, the nth term, so if I want to know the fifth term or seventh term, I just replace n with those numbers, is equal to a1, which is 8, plus, again I'm going to leave it as n minus 1, times d, and d being the difference is 13. I'm going to need to distribute to get a sub n equals 8 plus 13n minus 13, which gives me a sub n. The nth term in this sequence is 13n minus 5. Now I could also write negative 5 plus 13n. It doesn't matter, but this is the sequence. Now I want to know what the 20th term in this is. So I'm going to say, what is a sub 20? Well, it would be 13 times 20 minus 5. And 13 times 20 minus 5, just throw that in the calculator, and I will get 255. And there's my second answer. So with these arithmetic ones from 12.2, if I'm finding the function or the expression that tells me about the nth term, it's this equation right here. Substitute a1 and d in, simplify, and then substitute whatever I need in for n. As we continue on, let's go a little bit further into the assignment, and we're going to look specifically at number, let's look at 44. Okay, and some of this will look a little funny if you weren't in class before, but we have what's called the summation. I equals 3 up to 9. Let me find my spot in the book. Okay, 3 to 9, and my expression is 72 minus 6i. 72 minus 6i. Well, the thing is that I want to try, what this means is I'm going to try to add up all the answers, or all the terms, from the third term up to the 9th term. If I were to put in, the 3, then the 4, then the 5, 6, 7, and 8, and 9. That's quite a few terms. It ends up being that there's 7 things to put in and to simplify and then add together. Well, we learned in class that there's an equation for this, a formula. And the formula is that we take n times a sub 1 plus a sub n over 2, where n is the number of terms, okay? Or where a is the last term, okay? So 3 is going to be my first term, right? 3 is going to be my first I, and I'll work my way up. So if I think about it in terms of 3, 4, 5, 6, 7, 8, and 9, that should be 7 terms. So n is 7. Okay? So this equals 7 parentheses. Now I need to find a sub 1. That is going to be 72 minus 6 times my first value, which is 3. And 72 minus 18 is 54. So a sub 1 is 54. I'm going to add in the last term, which is a sub 7, because it's 7. But that's going to be when I plug the 9 in. It gets a little confusing with the labeling being off. But see how these are off by 2? Well, 9 and 7 are also off by 2. At any rate, 72 minus 6 times 9. Okay, that's 72 minus 54. And that gives me 18. Back to 18. All right, and so I put the 18 in here. I'm going to add those and divide it by 2. And then I'll multiply by 7. Well, 54 plus 18, of course, is 72. 72 divided by 2 is 36. So 7 times 36 is 252. What this means is that if I added up 54 plus the next term, plus the next term, plus the next term, all the way up till I get done with my last term, all 7 terms, I would have gotten 252. This is much quicker than having to write all 7 of those numbers out and add them together. When we switch over to 12.3, we switch the type of sequence that we're dealing with. Now we're going to be dealing with geometric sequences. And in 12.3, we're going to look together at problem number, let's take a look at, say, 18. Yeah, we'll say we're going to use 18 as an example. All right? And this has the numbers 7, negative 35, 175, and negative 875. We want to try to write the expression or equation for this geometric sequence. Well, 2 things I want to know. I need to know A1, which in this case is 7, and I also need to know what's called R, the ratio, okay? Which is really just what am I multiplying by each time to get to the next term. Well, I can take a term, negative 35, and divide it by the term prior. So if I divide by 7, I get negative 5. Well, I want to check that this works all the time, so let's take negative 875 and divide it by 175. Oddly enough, or perfectly enough, I get negative 5 again. So this right here is my ratio. I'll use negative 5. The reason I need those 2 values is that the expression for the nth term of a geometric sequence is A1 times R to the n minus 1. And so when I write this out, I'm going to write 7 parentheses negative 5 raised to the n minus 1. And so this right here is my expression to give me any term from this geometric sequence. But now I want to find a specific term. And I believe the textbook asks us for a sub 7. So what's the 7th term? Here's 4 of them. What's the 5th, 6th, and then finally what's the 7th? Well, what we're going to do is we're going to take 7 times negative 5 to the, well, if I want the 7th, I'm going to use 7 minus 1 is 6. And so now I can calculate out that 7 parentheses, negative 5, close parentheses, raised to the 6th is 109,375. Again, just application of using 7 for n to get 7 minus 1 is 6, and then just plugging it into the calculator. Pretty straightforward. But when we go into doing the summations, we do have to be a little bit careful. So let's take a look together at, say, number 52. Okay? I believe you do 52. So 52 says we have the summation again. To 12, we start with I equals 1, and we have 8 times 3 halves to the I minus 1. Okay, so I'm trying to find the sum of these 12 entries. Well, quite frankly, I don't want to find the sum of 12 different entries. It's going to be quite complicated to write all of them out. But there is, again, a formula that I can use, which tells me I'm going to take a sub 1 times, okay, 1 minus r to the nth power over 1 minus r. So a couple things I have to know. First thing I need to know is, what is a sub 1? Well, a sub 1 is 8 times 3 halves to the 1 minus 1. 1 minus 1 is 0, and anything to the 0 power is 1. So a sub 1 is 8. Okay. The next thing I need to know is, what's r? Well, r is always the value that has the that gets the exponent. Notice that 3 halves here is what we're using our exponent on, so that should be our value for r. And the last thing we need to know is, what's n? Well, in here, I start at 1 and I work my way up to 12. That should tell me that there are going to be 12 different values that I'm trying to add. Now I can use this formula. So I'll start with 8 parentheses, 1 minus 3 halves to the 12th over 1 minus 3 halves. And what I'm going to do, okay, as I go in and I go to calculate all this stuff, I want to be really careful and work one piece at a time. So what I'm going to do is, I'm going to use the answer key on my calculator quite a bit. And what I'm going to do is, I'm going to try to evaluate what I can by hand. Starting with the numerator, this is a beast. So I'm just going to type in 1 minus parentheses 3 over 2, close parentheses, to the 12th. And when I do that, I'll go 1 minus parentheses 3 divided by 2, close parentheses, raised to the 12th. Enter. I'm going to get something like this. Negative 128.74 dot dot dot. Okay, I've still got the 8 out here. In the bottom, 1 minus 3 halves. You know, if I can do this either by hand or in my head, it saves me a little bit. But what I'm going to do is, I'm going to type in negative. I'm going to use my answer key. So make sure that you have your answer, and then divided by. So it should say answer divided by. And then what I'm going to do is parentheses 1 minus 3 over 2, close parentheses. So 1 minus 3 over 2. When I put all that into the calculator, I'm going to end up with 8 equals, and this is the answer divided by this chunk in a parentheses. Okay. Again, you have to have that extra parenthesis down here to get, oops, to get 257.49 dot dot dot. Now I'm going to take that times the 8 to get that my summation equals 2059.94. And you know, you really don't have to have this go on forever, but you want it to be, you know, reasonably sized decimal. You can try to turn that back into a fraction, and if you do, and your calculator allows you to, you're going to get 527,345 over 256. So either one of these is definitely going to be an acceptable answer. We'll try to make sure we have both of them when we take and grade this on Thursday. Good luck. I hope that helps. Just remember, these formulas are really, really important, and without them, we're not going to get very far. So I'll have them in class when you need them, and good luck.